When Wi-Fi won't work, let sound carry your data. If you and #X27V ever struggled to pair your phone with a Bluetooth speaker or set up a wireless printer, you know that it and #X27's often easier to connect to a server halfway around the world than to a gadget across the room. That and #X27's a problem as we increasingly use our phones to pay for stuff, unlock doors, and control everything from televisions to thermostats. No one wants to wait for coffee because the cash register can and #X27 detect their phone, or shiver in the cold because their watch is trying to connect to their neighbor and #X27's door lock instead of their own. Multiple wireless technologies have emerged in recent years to tackle this problem, including Bluetooth, LoRa, and NFC. These technologies are all based on radio frequencies. But a growing number of businesses, from Ticketmaster to Google to nuclear power plants, are turning to a simpler solution: sound. Ticketmaster is working with Cincinnati-based startup Listener to create audio-based digital tickets. So instead of using a printed ticket or QR code on a phone to gain entrance to an event, your phone plays a short, inaudible sound. It's a bit like having your phone whisper a secret password to a digital assistant, like Apple's Siri or Amazon's Alexa, to gain access to an event. Justin Burla, VP of Product at Ticketmaster, explains that the company already enables event-goers to use NFC, the technology that powers Apple Pay, to gain admission at venues that use the company and #X27's presence software. But, he says, about 20% of Ticketmaster and #X27's customers don and #X27 have phones that support NFC. Bluetooth is nearly ubiquitous, but requires each phone to pair with the ticket-reading device. That would be a challenge when 1,000 people crowd around a gate at a venue. But every smartphone can play audio, and nearly every tablet and smartphone has a microphone, sparing venues from having to buy expensive new equipment. Using sound to transmit data is nothing new. Everything from bird chirps to human language can be considered a form of data over sound. It's old hat for computers too. The squeal of a dial-up modem is actually digital data encoded into sound and then interpreted by another computer. Unlike dial-up modems, this new wave of data over sound technologies transmits messages over the air, instead of over wires, even if you can and #X27 always hear the audio frequencies they use. Here's how it works. One device translates a chunk of data, such as a block of text, into a sequence of sounds that can be decoded by another device. The receiving device processes the audio and converts it back to the original form. The procedure is a bit like using Morse code to transmit a message, but more complex. Using Morse code, you can translate text into a series of audio pulses that someone else can decipher. It would take a long time to send a complex message that way, so instead of using a single tone, as Morse code does, programmers use a range of audio frequencies to pack more information into less audio. Developers have to carefully select the frequencies, and tune their software to filter out noise so that applications can detect and interpret data signals even in noisy places, like concert venues or sports arenas. Even using multiple frequencies, sound waves can only carry a limited amount of data, however. So developers use the technology primarily to transmit small files, such as a digital ticket. Google uses audio technology to pair phones with its Chromecast video devices. Using Bluetooth, your phone might not be able to distinguish the smart TV you're watching from a TV in another room, or in a neighboring apartment, says Google software engineer Brian Duff. Using audio frequencies that one and #X27 pass through walls, Google can pass an introductory message between your phone and Chromecast, kicking off the digital handshake that pairs it with your phone. From there, the two devices can use a higher bandwidth, radio-based wireless technology to transmit data, such as the video of a movie. Google offers this audio technology as part of Nearby, a software kit that helps Android developers add proximity-based features to their apps. Audio's ubiquity allows users to connect different types of devices without worrying about which technologies those gadgets support. For example, video game maker Activision Blizzard uses sound-based technology developed by a UK company called Chirp to enable players of its game Skylanders Imaginators to move character data between a mobile app and a video game console like a PlayStation or Xbox. The data could be transferred via the internet, but developers wanted to use technology that is simple enough for children and works offline. Data over sound is also useful in places where radio frequencies can and #X27:T be used, for practical or legal reasons. For example, UK-based EDF Energy uses Chirp and #X27:S technology in parts of its nuclear power stations where radio transmissions are prohibited. We are developing a way to connect mobile workers on tablet devices, reporting their progress through work, and also to connect sensors to make it easier for an engineer to monitor a plant when performing fault finding, says EDF Energy project manager Dave Stanley. It might not sound like a good idea to transmit something like payment credentials over the audio spectrum in, say, a coffee shop where anyone can theoretically listen in. But as with secure Wi-Fi and other cellular data transmissions, the data can be encrypted to protect it. Mick Grierson, a professor of computing at Goldsmiths, University of London, says that, done properly, audio could actually be a good way to send secure communications, because in many cases no one else will know that a message is being sent. He and #X27:S worked on projects where data is hidden in another sound. In fact, Grierson imagines future applications for data over sound in emergency and military communications. Wired gets a tour from veteran Foley artist John Roche of the Skywalker and #39:S custom-built soundstage. Roche reveals some of the strangest audio props that were used in films like in #39:, Who Framed Roger Rabbit, and #39, and #39:, Back to the Future and #39, and #39.